Go over physics exam number 3 solution. So let's get started with the problem number 1. Car A and car B, and car A is moving 20 meter per second and car B is moving with 15 meter per second. Both of them are constant velocity, meaning acceleration is 0. Acceleration is 0, of course. Now the car B is 200 meter behind car A. So you're going to use this as a reference point. So we're going to start measuring from here, and let's see what we can do. All right, so the car A equation for car A, let's see, d is equal to di plus bit plus half at square. D for car A, d for car B is equal to, of course, di plus bit plus half at square. Of course, let's see, di, we can say di is 200 for car B, because car B has a head start. Vi is 15t and acceleration, of course, is 0. So dA is 0. This car doesn't have head start, plus 20t, and this is 0, of course. So we can set dA equal to dB, and we can take it from here. So dA is equal to dV. So dA is 20t is equal to 200 plus 15t. So 20t minus 15t is equal to 200. All right. So 5t is equal to 200. T is equal to 40. Okay. So as you see, t is equal to 40. Now we can put that over here. So then it's 20 times 40. So dA is 800, and we can put dB is also gonna be 15 times 40. So 200 plus 600, also 800. So 800. So they're gonna meet somewhere over here. Okay. So at 800 a meter, they will meet together. So the answer to question number 1 is, of course, 800. Question number 2, I kind of went over this question. Remember I gave you the example of terrorist. So I don't know. So this guy is here and this guy is here. All right. Both of them are on the same rooftop of the same building. Say this is 50 meter above the ground, 50 meter above the ground. Okay. So this guy is chased by a terror, and this guy also chased by a terror. All right. So this guy decided to jump. A is 15 meter per second, and B, let's call it B, A, and B is also 30 meter per second, double. Okay. Now who gonna land on the ground faster? Okay. All right. So both gonna land on the ground at the same time, because the velocity is horizontal. Horizontal velocity only contribute to, so velocity has two components, Vx and Vy. Okay. Vx only affect the range and Vy affect the time. So since this is a Vx and Vy, of course, is 0, because let me give you an example. If you are on the rooftop of a building, or you are on a table. Okay. So let's say this is top of Mr. Barry's table. Mr. Barry's table. This is a marble. So you push the marble with, I don't know, 10 meter per second. All right. 10 meter per second. Velocity is 10 meter per second. So the marble rolls, come to the edge, and it's just gonna falling. So when falls, the Vx is 10 meter per second, no friction, and Vy is 0. Okay. All right. So remember that. Okay. So if this is the case, then Vy is 0 for both problem. Therefore, the time it will take at the same time. The time will take the same time. So let me go problem number 3. Number 3, an object is moving 2 meter per second for 6 seconds. How much distance object can can move. All right, so we can do a dt graph and vt graph. So this is going to be easy. So there the object is moving, so this is a dt graph. Object is moving, velocity is 2 meters per second. So this is going to be 2 meters per second, and this is going to be 6 seconds. So so this is 12 meters. So the object moves. This is 12 meter. Okay, so this is 0 meter, this is 12 meter. Let's see whether that makes sense. So velocity is df minus di and tf minus ti. So df is 12 minus 0 and 6. So velocity is 2 meters per second. All right. So you're going to drop it. When you're dropping an object, initial velocity is 0. And when you drop it, the object, the end of first second, end of second second, end of third second, right? End of first second, the velocity would be 10 meters per second downward. End of second second, velocity would be 20 meters per second downward. End of third second would be 30 meters per second downward. Now that is actually take 3 seconds for object to accomplish 30 meters per second velocity. So how can we do that? Pretend that you don't know this information. So Vf is equal to Vi plus At. What is given? This one is given, negative 30. What is given? This one is given, 0. Minus 10t. Of course, t is 30, negative 30 over negative 10. So t is equal to 3 seconds. All right, this is how we can figure out that. This is another way of figuring out that is 3 seconds. Is an acceleration problem. So a car start a velocity initial 0 and it moves about 100 meter. Velocity is 15 meters per second. So what do we want to know? Acceleration. What would be the acceleration? So this is we can find acceleration by Vf squared is equal to Va squared plus 280. So Vf squared is of course 15 squared, Va squared is 0 squared plus 2. Of course acceleration, that's what we need, and d is 100. So we see that acceleration is 15 squared over 200. So 1.125. So acceleration is, let's say I want to have one decimal place, 1.1 meters per second squared. And this is the answer for problem number 5. Now we're going to do problem 6. Number 6 we're going to go over now is also free fall, and this is throwing downward. Throwing downward means velocity initial has to be less than 0. How can it be done? So let's say you are on the rooftop of a 4 meter tall building and you throw down a ball with 0.5 meter per second, and the ball gonna, instead of doing like this, the ball gonna go like this, and we want to find the velocity of the ball when the ball is spent 0.7 second in the air. So pretty much you're going to use Vf is equal to Vi plus At. Vf is, of course, that's what you try to find, or you want to find the speed. It's the same thing. Vi is, don't forget this is throwing downward, so you have to put negative 0.5 minus 10 t. Vf is equal to negative 0.5 minus 10, and this is 0.7. Okay, so Vf is equal to minus 0.5 minus 7. So Vf is equal to minus 7.5 meter per second. Of course, you take the absolute value, so this become just 7.5 meter per second. And the acceleration, so what would be the acceleration when a runner run 12 meter? So this is distance is 0, this is distance is 12 meter. T is equal to 0 second and t is equal to 4 seconds. So what would be the acceleration? So we can find it, d is equal to Vit plus half At square, of course. So now d is 12, so this is 12 because this is change in d. I prove it in the class where it is change in d, and velocity initial is of course is 0 because because he started from rest. So half a, that's what we want to find, and t is of course 4 squared. So 12 is equal to 16, 8, 8a. So a is equal to 12 over 8. So 3 over 2, so 1.5 meter per second squared. Is the easiest problem. I gave you a mass, instead of mass, this time I gave you the weight. The weight falling, so it doesn't matter what is falling, weight is falling. Weight is falling, I want you to find how much does it fall fast 1 second. Fast 1 second. 1 second it falls, it's pretty easy, it falls 5 meters. If you use negative 10 as acceleration due to gravity, 4.9 meter if you take negative 9.8 as acceleration due to gravity at the end of 1 second. How do you find it? Okay, just pretty easy. So d is equal to VAT plus half at square, and d is what you try to find is equal to VAT is 0 because you're dropping it, half negative 10, of course, and the t square is 5, 1 second is 1 square, which is 1, this is 5, so d is equal to negative 5. The magnitude of the acceleration given in this equation, given this data. We're going to say Bf minus Vi, Tf minus Ti. So Vf is going to be what? 8.5. 8.5, and Vi is equal to what? 4. Tf is 6 minus 3. So of course this is 3 and this is 4.5. 4.5. So 1, so 115. So this is 1.5 meter per second square. So acceleration is 1.5 meter per second square. The Neil Armstrong on the moon drove a hammer. Okay, so drove a hammer on the moon and 2 meters above the ground. So this is moon and this is 2 meters. All right, and the hammer is 2 meters above the ground, and acceleration due to gravity on the moon is of course 1.62 meter per second square. Don't forget the negative. Find the t when the hammer touches the ground. What would be the t? So d is equal to VAT plus half at square, and that distance is negative 2. VAT is 0 because you're dropping it. You dropping means velocity initial is 0. So half negative 1.6 t square. So t square is going to be negative cancel, of course. Let's write 2. 2 is equal to this is 0.8 t square. All right. So let's do t square is equal to 2 divided by 0.8. Okay. So then t square is equal to 20 divided by 8. So t square is equal to 2, and this is 5, right? All right. So t square is equal to 2.5. So t is equal to about 1.6 second. What do we have? dt graph. So you have an object that is accelerating, moving like this, and then moving A to B to C to D to E. Now let's see. This is of course quadratic. This is of course linear. This is constant, and this is of course linear. To be more specific, this is y equal to ax square plus bx plus c, y equal to mx plus b, y equal to c, y equal to negative mx plus b. So if you do the VT graph for this one, what are you going to see? You're going to see this one, of course, a diagonal line, number one. This one is of course a horizontal line, number 2. This one of course 0, and this one of course negative. So this is 2, this is 2, this is 3, this is 3, this is 4, this is 4. So if you analyze it, if you do the acceleration, then what do you want to see? Acceleration versus time graph. Okay, you're going to see the acceleration is positive over here. So acceleration, this is at. So section A, acceleration. Section 2, 0. Section 3, of course, is 0. And section 4 also, of course, 0. So object is accelerating only at where there is a quadratic motion. 12, I give you a dt graph. So 1, 2, 3, 4, dt. Object is first 2 seconds, object moves with constant velocity, and then object is at rest from 2 to 4 seconds, and then 4 to 5 seconds, object moves with constant velocity but toward the origin. Okay, so what I want you to find, average speed. All right, so there are 2 ways to find it. Average speed for first 4 seconds. 2 ways to find it. So speed is, of course, df minus di, tf minus ti. So df would be okay. So this is 1, 2. This is 2. 2 minus 0, and this is 4 minus 0. So 1 over 2 is 0.5 meter per second. This is average speed. We can do it different way by converting it to vt graph. So this one gonna be a horizontal. What would be the velocity of this piece? Let me see. So velocity of this one would be v is equal to df minus di tf minus ti. So the df is 2 minus 0 and 2 minus 0. So this is 1. So velocity is 1. This piece velocity is 0. Okay. So this is 2. This is 4. And this piece velocity is, okay, df minus di tf minus ti. So the df is, of course, 1 minus di is 2 divided by 5 minus 4 is 1. So this is minus 1. So this is velocity is minus 1. Minus 1. So we don't need this part because we want to find the average velocity or average speed for first 4 seconds. This is 5 seconds. So we don't need to go beyond 4 seconds. So average velocity is vf plus vi and divided by 2. So vf is, of course, what is the vf over here? Vf is 1. Okay, so vf is 1. 1 plus 0 divided by 2. So 1/2, which is, of course, 0.5 meter per second. Speed versus time. Speed in meter per second, time is in second. So what I have 1, 2, 3, 4 seconds, and what I have 2, 4, 6, 8, and 10 meter per second. So the object moved 4, 10. This is how much object moves. So what I want you to find the distance object moves at first 3 seconds. So distance object move first 3 seconds is this one. This one. Okay. This. So distance is equal to half bh. So half b is 3 seconds, h is 8, 4, so 12 meters. So object moves fast 4 seconds, 12 meters. Okay, so number 14 is you throw up what? A baseball. Now find VT graph. Of course, you start with DT graph. How the DT graph should look like when you throw up. Okay, so you have to throw up with a initial velocity. So let's say initial velocity. When you throw upward, initial velocity has to be greater than 0. So it doesn't matter what is initial velocity. So this is how it should look like. Now convert it to VT graph. Okay, so where is the velocity is maximum? So velocity is maximum. So this is v. V can be, I don't know, any number. V can be 10. So this is v is negative 10, and this is v is of course 0. So the velocity is 10 over here. So put 10. This is VT graph, and velocity is negative 10 over here, negative 10. And this can be, it doesn't have to be 10. It can be any number, any number. If 2, it doesn't matter. And put the 0 over here. Okay, so there is the same amount of time. Okay, so and that's how you're gonna do it. This is the VT graph for an object that you throw up to the air. Just for 15. All right, so we have 0 to 5 second, 1, 2, 3, 4, 5 second, and negative 10, 10, 20, 30, 40, and 50. So something is moving from 0 to 5, 50, 5, 40, 5, 40. So 5, 40. 5, 40. Okay, that's it. We want to find the acceleration. This is Vt. Now we want to find the acceleration. So acceleration is Vf minus Vi, Tf minus Ti. So Vf is what? Vf is of course 50. Vi is negative 10. And Tf is of course 5 and 0. This is 0. Okay, so now this is 50 minus plus 10 over 5. So 60 over 5. So 5 goes to 6 once, 110, so 12. Car velocity is 16 meters per second and is come to rest at 4 seconds. After 4 seconds, it come to rest. How much distance? So we want to know how much distance the car travel before it come to stop. So let's first find the acceleration. It's a two-step. We're going to solve it. Vf minus Vi, Tf minus Ti. So acceleration is Vf is 0 minus 16 and Tf is 4 minus 0. So acceleration is of course minus 4. Okay. Why minus 4? Because the car is the velocity is the direction, acceleration is the direction, car slow down. Okay, so Vf square is equal to Vi square plus 2AD. Okay, Vf square has to be 0. Vi is of course 16 square plus 2 minus 4 and d. Okay, so 16 square, so you have negative 16 square is equal to negative 8d. Okay, so 16 square, so d is equal to negative cancel, so 16 square over 8, 32. So the car moves 32 meters before it comes to a stop. Moves initial velocity is just opposite. Initial velocity is 8 meters per second and final velocity is double, 16 meters per second, and let's say it takes only 10 seconds for the car accomplish this speed. I want to find the d. So how can I find the d? Well, it's simple. First find the acceleration. Vf minus Vi is equal to Tf minus Ti. Of course, acceleration is 16 minus 8 over 10 minus 0. So acceleration is 8 over 10. So acceleration is 0.8. Now to find the d, you have to do Vf squared is equal to Vi squared plus 2AD. The final velocity is 16 squared. Initial velocity is 8 squared plus 2. Acceleration is this time, the velocity is this direction, acceleration is this direction, the object is speeding up, of course, 0.8, and the distance, that's what we are trying to find. So 16 squared minus 64 is equal to 16, right? 1.6 d. So d is equal to 16 squared minus 64 over 1.6. So d is equal to 120. A runner starts with, say, initial velocity and final velocity is 8 meter per second. So he uniformly accelerates in, let's give you time. He accomplished this in 4 seconds. So acceleration is of course Vf minus Vi and Tf minus Ti. So Vf is 8 minus 0, 4 minus 0, so 2 meter per second squared. All right, so 2 meter per second squared acceleration is constant 2 meter per second squared. Yes, I'm going to take you to a planet, I don't know, X, not Earth. We're going to have a mass, you're going to drop it. So when they drop something, velocity, of course, initial velocity is 0. So it falls, I don't know for how long, I don't know, t is equal to 0.63, I believe that's what I give you. And it falls the distance of 0.72 meters a second. What we want to know is the acceleration of this planet. So what are you going to do? D is equal to VAT plus half AT squared, of course. D is negative 72.72. Velocity, of course, is 0, half. A, that's what we find, and the time is 0.60 squared. So A is actually, so we can say negative 0.72 is equal to 0.5 times 0.63 squared. Of course, A. So A is equal to this is negative, of course. Negative, I mean 0.72, 0.5 times 0.63 squared, 3.6, of course, negative meter per second squared. So this is bigger than Moon and is smaller than Earth. This planet is bigger than Moon, smaller than Earth. All right. Okay, so let's do number 20, and 20 is the last problem. Draw acceleration versus time graph from right here. All right, so let's do it. If the velocity versus time graph is horizontal, acceleration is 0. Okay, if this is horizontal above the x-axis, this is horizontal 0. If this is horizontal 0, this one has to be horizontal 0. Now there is an acceleration over here, and that's what we're going to find. So acceleration is velocity final minus velocity initial, t final minus t initial. Velocity final is negative 8. Velocity initial is 8. T final is 10 minus 6. So minus 16 over 4. So this is minus 4. So acceleration is minus 4 from 6 to 10. So minus 4 from 6 to 10. From 6 to 10, acceleration is minus 4. And that was beautiful, right?